So let's talk about how we would write our complex number in trig form, or rather standard form here. So here, again, it's the same picture we've seen so many times, right, throughout the entire class, except notice this time that y-axis is the imaginary axis instead of being the y-axis, right? So if our complex number is a plus bi, a is the real part, b is the imaginary part, right? If we look here, this is still x, just kind of thinking about our rectangular. This is still y. We still have r, which is the radius of our circle, which is the hypotenuse here. And a would be the same thing as r cosine theta, right? And b would be r sine theta. And r squared is a squared plus b squared. And the tangent of theta would be b over a, right? And this is going to be another one of those situations where we're going to need reference angles, right, to get there. So I want you to pay attention to the formula down here, the trig form of a complex number. So the standard form is a plus bi, and z is our complex number. Trig form, r cosine theta plus ri sine theta, right? That's where that original part, that imaginary part goes, right, is with the I. And so then what we typically do is factor out that r, and notice then we have cosine theta plus I sine theta. That'll be a button in ALEKS that you'll be able to click, like we could with the plus 2 pi k, where k is in z, right? It'll be a button. But I want to share with you my little abbreviation. So when I talk about these, I will abbreviate it as r cis theta. So there's the r, the c is for cosine, the I is for the imaginary, the s is for sine, and your theta. So for me, it's a way to just abbreviate when we're writing, so you don't have to write out cosine theta plus I sine theta every single time, but just know that that's what it is, because in ALEKS, you don't have that abbreviation. You do have to type it out or use the button. All right, so it says write the complex number in standard form, rectangular form, which means we're turning it from this trig form into a plus bi. So we have our r value, and remember our a is r cosine theta, right? Our b is r sine theta. So what we're going to do is we're going to talk about 5 pi over 4 first. We know that all of our over 4s are root 2 over 2, root 2 over 2. And 5 pi over 4 is in the third quadrant, right, where we are negative, negative. So that means that my a value is going to be 5 times negative root 2 over 2. Plus my b value is going to be 5 times negative root 2 over 2. And then we need the I on the end. So we're going to have, what, negative 5 root 2 over 2 minus 5 root 2 over 2 I. So we're just going back to the unit circle, right, pulling out our values. So looking at the next one, if I'm talking about 300, If you want to talk about 300, you can think about the reference angle, which is 60 degrees, right? And so my 60 degrees are all 1/2 root 3 over 2. And 300 degrees is in the fourth quadrant where we are positive, negative. So then my A value is the 4, which is my R, times the cosine of 300, which is 1/2, plus the 4 times the sine of 300, which is negative root 3 over 2, I. So 4 times 1/2 is 2. Let's see, we're going to have a minus, right? My 4 and my 2 are going to cancel. 2 root 3 I. The only caution I'll give you here is when you put that in Alex, you want to be sure that you get out of that root, right, before you type the I. Easy enough, right? All right, so if we have 180 degrees, at 180 degrees, my ordered pair is -1, 0, right? So I'm going to have 6 times -1, which is -6. And we're not going to have an imaginary part at all, right? Because the sine of 180 is 0. And then for the last one, looking at 5 pi over 6. All of my over 6's are root 3 over 2, 1/2. 5 pi over 6 is in the second quadrant, right, where we are negative, positive. So we would have 7 times negative root 3 over 2 plus 7 times 1/2 I. So -7 root 3 over 2 plus 7/2 I.